Welcome everyone to the very first video of WeatherIQ, where we take a look at the weather in question. Well, here in the United States, we are just about in the dead middle of tropical season and approaching our peak in September. So our first video is going to be all about tropical, and we're actually going to take a look at just how much goes into a tropical forecast. Now, there are several elements to that. This one specifically will only be focusing in depth on the aspect of heat and what that does to a tropical system. Now, starting off the tropical forecast, the National Hurricane Center would lead you to believe that there's nothing going on in the Gulf or in the entire Atlantic. Now, that's not necessarily true, and I don't mean to be misleading by that. I'm not trying to go against what the National Hurricane Center has put out as far as the actual operational forecast, but I do want to highlight that there is activity, just not of the level to where we need to be concerned right now. Now, our first product that we're looking at, this is the water vapor. It's from the GOES 16 satellite, which is the newest GOES East. And if you don't know, a GOES satellite just means that it is geostationary. And geostationary means that it stays still with respect to the actual Earth. So you can see that there is no rotation. There is no rotation from left to right as far as this satellite goes. So it stays over the same location as the same rate that the Earth actually rotates. This particular band of the satellite, that you can see there are several bands over here on the left. This particular band is the mid-level water vapor. So that is examining the water vapor specifically from about 10,000 feet to 18,000 feet. That's about what we consider the mid-layer of the atmosphere. So it just allows you to see kind of the core water vapor that's going into everything. Water vapor is not necessarily clouds, although clouds are made up of water vapor, but it does show how much available moisture is there. Now, the first thing I want to bring to your attention is this little invest just west of the Lesser Antilles here. This invest, about 2 days ago, started off as a very, very small group of thunderstorms and has grown since then, and we're going to see if we can figure out why it's been growing. Now, I also want to take a look at these systems here. There's this one here and this one here. Those previously were just over South America and have been transversing across the terrain there. There's a bunch of mountain ranges across that area, and they've also stayed mostly over land, which is why they haven't been able to grow. So we're going to look at why it is that this invest has grown. Here's a second product I wanted to highlight so we kind of get a better idea of what it is that's going on here first. Now, again, I pulled attention to this one here, this little invest just west of the Lesser Antilles. Then I also pulled your attention towards this and towards this. Again, they stayed over land, so they couldn't do a whole lot. And again, we're going to look into why on that. And then this one has stayed over the water. Now, this product is the infrared. Infrared is literally just taking that portion of the spectrum that's just a little bit higher than what we can see. So we can see from about violet to red, right? Well, infrared is just a little bit higher and allows you to see how much heat is actually coming off of an object. So the advantage of that when it comes to clouds is that the amount of heat that they put off and their exact temperature directly correlates to their height in the atmosphere. So that tells us immediately that with these reds and grays and blacks, that this cluster of thunderstorms is actually at a higher growth height within the atmosphere than this actual system is just west of the Lesser Antilles. So that tells us just how much growth might be in a system. Now, more than that, we actually need to know the temperature of the water, not just the temperature of the clouds. So here is the sea surface temperature product. That's literally what it's showing us, is just the top slice of the ocean and how much heat is in that. You can see right where that system was west of the Lesser Antilles. That's approaching the upper 25 degrees Celsius range, but not quite to 30 degrees Celsius. The minimum temperature required for any sort of tropical development is 26.5 degrees Celsius, or somewhere around 80 degrees Fahrenheit. If you don't have that, it cannot grow. There is not enough energy in the system. Now, I also want to pay attention to the fact that this entire area here, from west of the Lesser Antilles to right here just south of Cuba and into the Yucatan Peninsula, this is all in that orange range. And then when you get into the Gulf of Mexico, that's where you start getting into closer to 30 degrees Celsius range. That'll become really important here in a minute when we transition away from the sea surface temperature, because sea surface temperature is not the entire picture. You see, when tropical systems really develop, they create a lot of turbulence on the waves because the wind speed is picking up and it's really growing in how much strength it has. The more that those waves actually get churned up and mix, the more colder water from below the surface will start to mix up to the surface and therefore start to cool it down. So in essence, the growth of a tropical system ends up becoming its downfall because it's mixing up all this cooler water. To change that fact and still use all this heat to our advantage, we developed another product. This product is the Tropical Cyclone Heat Potential, or the TCHP. Now, the TCHP looks a little bit different than the sea surface temperatures, and here's the reason why. Because those ocean waters get churned up and that temperature changes, we need to know not only how hot the sea surface temperature is, but how hot is the water that's below the surface. So what the TCHP is the average temperature from the surface of the water down to the lowest height where it's still 26 degrees Celsius. So in other words, if you've got a really deep hot temperature profile, say right here that we talked about just south of Cuba, that means that high temperature extends far down below the surface of the actual ocean. Now, that depth could be 10 feet, it could be 500 feet. This allows us to tell where the most stacked warm water really is. So in essence, the Gulf of Mexico, we looked at it having the highest actual temperature, but in reality, it's only right on the surface. When you go down below, that temperature drops rapidly enough that the TCHP is not very high. In fact, there's only this one little hotspot just south of Louisiana right there. Whereas right here, south of Cuba and kind of approaching the Yucatan Peninsula, this area was not as high, and yet the TCHP is the highest value on the entire map. That is what allows us to really tell how much heat is going into this system. We've seen the sea surface temperature and we've seen the TCHP, but you don't need to just know the current temperature. It's really useful to know how different is that from the average. For that, we use this product right here. This is the temperature anomaly. So this is basically how far are we different than the typical average for an area. So using this, we can actually see that the temperature west of the Lesser Antilles is actually higher than average by about 2 degrees Celsius. And the Gulf of Mexico is higher than its typical by about 3 degrees Celsius. And that's huge to know, okay, well, where are we compared to our average in this season? And where should we expect development? In later videos, we'll talk a little bit more about where hurricanes come from and where they form and why. So I'll go ahead and point out at the same time, just off the coast of Africa, look how much cooler than average that entire region is. Almost the entire area is at a -1 to -2 degrees below the actual average temperature for that area. And that's where a lot of our hurricanes tend to come from. They don't just form in the Gulf or transit their way through this same path that system's taking we've been looking at. They actually tend to come from right here. And again, we'll go through that in a later video, but I just wanted to point out this entire cold pool here compared to the warm one here, that plays a huge factor in just what is going to form in this area. Now, taking everything that we just talked about as far as heat goes, we should be able to expect that if this system continues pushing west, and we'll talk later about where it should go and why, but if it continues going west, we should be able to expect that if all other conditions are favorable, that we should see growth as it approaches That area of high TCHP that we saw, not only is it above average on the sea surface temperatures, and it also has the correct temperature needed for it to maintain and grow, but on top of that, it's heading into a very deep energy pocket. That's all for this video, everyone. Thank you for watching, and big thanks to our sponsor, Radar Omega. They make these videos possible. If you liked it, go ahead and hit that like button. If you didn't, you also know what to do. And lastly, if you think I deserved it, go ahead and hit that subscribe button and come back tomorrow to continue raising your weather IQ.